Hey, Tom Casey here today talking to you about your air conditioning design temperatures. You know, as engineers, when we design your air conditioning system, we look at the temperatures outside to say how much cooling capacity do we need at the hottest times in order to cool the house. But there's some rules we have to follow as engineers. The first rule is there's a bunch of things called weather data, which tells us by city and geography what the typical design condition is during summer, the hottest temperature for 1% of the hours that we'll see, and that becomes our design condition. It could be anywhere from the high 80s in the northern climate to the mid 90s in the southern climate. Now this may not be the most extreme temperature we'd ever see. It's the collection of hours that make up about 1% of the maximum hours in any geographical location. So let's just assume 90 to 95 degrees for purposes of this video. Now, when we design the actual capacity of the air conditioning, we're also regulated by code for what we design it to. Energy code says that we can design the cooling system for a minimum temperature. The lowest setting that we are allowed to design to is 75 degrees. So then we have a temperature differential. Whatever our design condition is outside, minus 75 degrees is our differential. So if I have a 95 degree climate design based on my geography and based on the ASHRAE 1% weather data, and I can go to 75 degrees by code, I then have a 20 degree temperature difference as my design. If I have a 90 degree temperature outside design, ASHRAE 1% weather data, 90 to 75, I have a 15 degree temperature difference in my design from inside to outside. Now, one of the challenges we run against with that is some of us like it colder than 75 degrees inside. Some of us like it 74 or 73 or 72 or 70 or even into the 60s. Well, we can't design things like that as engineers and contractors without violating the rules of code. So we have to design and stick to our engineering guidelines, and that means there could be times on those design conditions that 1% of the hours during a season that the temperature might drift. And here's how it happens. Let's say that my design conditions are 95 degrees and I design to 75 inside. So I have a 20 degree split from inside to outside. But it's an exceptionally hot day. It's a heat wave. It's a record breaker. It's a scorcher. And it's 98 degrees outside. I still would have that 20 degree split from inside to outside during those peak hours when it's that 98 degrees. So my temperature might drift from 75 up to 78. I'll drift that difference because my design is 20 degrees from inside to outside. So as the temperature drops down from 98 to 97, I'll drift down a degree. 97, 96, I'll drift down a degree. 96, 95, I'll drift back down. And when it goes below that, then I'll actually be able to drift even lower if I want to in my set point. The point is that there's going to be times during the operation of a system, no matter what geography, no matter what climate zone, where we might exceed or even be at design conditions, and it might alter the actual ability for our system to maintain a temperature below what code allows. So if I like it at 72 degrees, but I've got a system designed from 95 to 75, 20 degree split, and it's 95 degrees outside, my system might drift up to that 75 degree level for portions of the day, even though I set it to 72, because design conditions are to maintain a 20 degree split. So that's what design conditions are. That's how they can affect the operation of your system. Now we can verify things. We can come out, we can check the refrigerant charge using the superheat subcooling method. We can verify the airflow, that the cubic feet per minute is correct. We can take what's called a temperature drop, the temperature split between the return air and the supplier, to make sure that's correct based on humidity levels. We can even take a temperature rise of the outdoor condensing unit to make sure it's rejecting all the heat it can. But if it's a design condition day and we verify that everything's working perfectly at maximum capacity, it just might be that the design conditions allowed to us as engineers might not be quite in sync with what you want as a homeowner or a building owner for that period of time. But don't worry, as soon as that temperature slides back down, you'll drift back down to the set point that you want. Boom.